All right, so yeah, continuation of the matrix video. So I did an example on non and not commutative matrix. I think I'm going to do another one. Then we're going to look at equality. Then we're going to look at singular. We're going to look at let me see. Yeah, let's just do it rather than just say it. Let's just do it. Let's just get into the video. All right. So let's say we had two matrix. We had M, and let's say M is 5, 4, 3, and 2. And let's say we had another matrix T, and T is let's see 1, 3, 2, 1, for example, and we want to determine if MT is equal to TM. Otherwise, we need to determine if they are commutative or not commutative. So otherwise, determine if MT is commutative, MT and the TM are commutative or not commutative. So let's see. So the first thing we need to find is MT. So this one I'm going to skip steps with the multiplication because it's reasonably easy. It's just that it takes a bit of practicing. Yeah, that's it. Just take a bit of practicing. So it's 5, 4, 3, 2, and T is 1, 3, 2, 1. So let's begin. So it's, remember, it's first row by first column. So it's 5 times 1, which is 5, plus 4 times 2, which is 8. That is the first row, first column. Then we move on to first row, second column. So it's 5 times 3, which is 15, plus 4 times 1, which is 4. So that was the first row, first column, first row, second column. Let's go on to the second row, first column. So it's 3 times 1, which is 3, plus 2 times 2, which is 4. Then we'll finish with the second row, first column. We're moving on to the second row, second column. So it's 3 times 3, which is 9, plus 2 times 1, which is 2. Then we're going to add. So it's 5 plus 8, that's 13. 15 plus 4, that's 19. 3 plus 4, that's 7. And 9 plus 2, that's 11. So this is what MT is equal to. So now I'm going to find TM. So T comes first. So T is 1, 3, 2, 1. M is 5, 4, 3, 2. So what we're going to do, we're going to multiply first row, first column. So it's 1 times 5, which is 5, plus 3 times 3, which is 9. That is the first row, first column. So moving on to first row, second column. So it's 1 times 4, which is 4, plus 3 times 2, which is 6. So that was the second row, second column. So now we're moving on to second row, first column. So it's 2 times 5, which is 10, plus 1 times 3, which is 3. Then we move on to the second row, second column. So it's 2 times 4, which is 8, plus 1 times 2, which is 2. Then we just go ahead and add. So this is what? 14. This is 10. This is 13. And this is what? 10. So that's what TM is equal to. So if you realize, we get two different answers for MT and TM. So once the answers are different, we can say therefore MT and TM is not commutative. They are not commutative. Now let's look on equality of matrix. Let me do this on another sheet. Now equality of matrix, it's very simple. So I'm just going to go through probably about 1 or 2 examples, because I'm going to make a video on some past questions related to matrix as well. Not the transformational matrix, but the ordinary ones that we're doing. So I'm going to do probably a video on that. Alright, so let's say we had matrix A, and matrix A is A plus 1, 3, 2, and B plus, let's say, 5. We have another matrix B. Matrix B is, let's say, 9, 3, 2, and 7. And this is solve for A and B, given that matrix A is equal to B. Matrix A is equal to B. Now, what they're saying that A, so we just write it down, A is equal to B. So A, matrix A is A plus 1, that's the first element, 3, 2, B plus 5 is equal to 9, 3, 2, 7. Now, solving for A and B, what we're going to do, remember, this is A, general A, this is B, this is C, this is D, this is A, this is B, this is C, this is D. So what we need to do, we need to equate the corresponding terms. So we're going to have A equal this A here, so it's actually A plus 1 being equal to 9, 3 is equal to 3, 2 is equal to 2, and B plus 5 is equal to 7. So if you realize these are equal to each other, so what we need to do is we need to solve these two linear equations to solve for A and B. So I'm going to have A plus 1 equal 9. I'm going to collect like terms. I'm going to have A is equal to 9 minus 1. A is equal to 8. Then we're going to solve for B. So B plus 5 is equal to 7. What is here? So B is equal to 7. Rub this out. 7 minus 5, because I'm collecting like terms. This is positive 5, bring to the equal sign, turns negative. So B is equal to 2. So A is equal to 8, B is equal to 2. Let's test to see if my answer is correct. Remember, whatever value A is, when I substitute it here, I should get 9. So 8 plus 1, 9. See it? And right here, whatever value B is, when I add it to the 5, I should get 7. So B is 2. So 2 plus 5, 7. So that's how you solve that question. So equality of matrix, it's very simple. Let's do another one. Let's say we had so those were two 2 by 2 matrix. Let's say we had just part this off, use this space to solve another question. So let's say we had, so we're still on equality. We did non-commutative a while ago. We're going to look at equality. So we're on equality. Then we're going to look at singular and non-singular matrix. I think we might look at how to find determinant and inverse first. So let's look at another question. Let's say we had a matrix M. M is equal to, let's say, K plus 3. And let's say this is what, let me use another, so something easy to recognize, T minus 4. So that is matrix M. So looking at matrix M, it's not a 2 by 2 matrix, it's a 2 by 1 matrix. So K plus 3 is one term, and T minus 4 is another term. Didn't even realize that the camera is reflecting there. All right, so we have another matrix N, which is equal to, let's say, 5 and 3. And they said that given that M is equal to N, solve for K and T. So remember, what we're going to simply do is just write M is equal to N. Then we write K plus 3, T minus 4, is equal to 5 and 3. And if you realize both matrices, they're of the same order. So we're just going to equate the corresponding terms. So we're going to have k, do it on this side and solve it quickly. So k plus 3 is equal to 5. K is equal to 5 minus 3. K is equal to 2. So remember, we're going to collect like terms. This is positive 3. When it goes over the equal sign, it turns negative. So 5 minus 3 is 2. Then we're going to have what? T minus 4 equals to 3. Collect like terms. I'm going to have T equal to 3 plus 4. This is negative 4. When it goes over the equal sign, it turns positive. So T would be equal to 7. So that's that for that. That's very, very simple. All right, so let's go on to something else. Let's look at how we can find the determinant of a matrix and the inverse. That's what we're going to look at. So let's say we had a matrix. Let's say we had a matrix. Sorry for the reflection in this video. All right. To realize that was what is going on, but let's just continue. Hopefully you'll see it properly. So sorry about that. Yeah. So let's say we had a matrix A. A is A, B, C, D, and we want to find the determinant of A. So this is how you denote the determinant. So determinant is equal to AD minus BC. So that is how you find determinant. Now the adjoint, so we can find the determinant. The determinant is AD minus BC. Now how we find the adjoint? The adjoint is what you're going to do. You're going to switch the values in the leading diagonal. So I'm going to have D up here. I'm going to bring A down here, and then I'm going to change the values in the minor diagonal for the numbers or letters. So if this is positive B, it's going to turn to negative B. If this is positive C, it's going to turn to negative C. So remember, if it was negative C, it would be positive. If this was negative B, it's going to be positive. So we just change the sign. So that would be the adjoint for A. Now the inverse of A would be equal to 1 over its determinant multiplied by the adjoint, which is D minus B minus C and A. So that is how you find the inverse. So I'm going to actually go into questions. So let's say we had a matrix. So B is 2, 3, 4, and let's say 1. I'm going to change this to 10. So let's change that to 10. So let's say we want to find the determinant of B. So determinant of B, remember, the determinant of any matrix is equal to AD minus BC. So this value is A, this value is B. So as I said, sorry for the reflection in this video. I'm just going to continue that. I'm just going to finish this one. So this is C, this is D. Hopefully you're seeing it, because I wasn't paying attention to the camera. All right, so what we have is we're going to multiply 2 times 10. 2 times 10, remember bracket means multiply, minus B times C, which is 3 times 4. 3 times 4. So I'm going to have 20 minus 12. So that is going to be equal to 8. So the determinant is 8. So the adjoint, the ADJ for short, the adjoint, what I'm going to do for the adjoint, remember, for these values, I'm going to switch them around, switch places with each of them. So I'm going to have 10 up here, I'm going to have 2 down here. The signs on these, I'm going to change them. So both of them are positives, I'm going to change them to negative. So it's going to be negative 3, it's going to be negative 4. So that's the adjoint. Now to find the inverse, remember the inverse of B, B to the minus 1 denote the inverse, is equal to 1 over its determinant. See it here? 1 over its determinant. Remember, determinant is 8, so it's going to be 1 over 8 multiplied by the adjoint. The adjoint is this, which is 10 minus 3 minus 4 and 2. That's the adjoint. So we just expand this, and that would give us the answer. So remember, this is a scalar multiple, so I'm going to multiply each term in the bracket by the 1 over 8. So I'm going to get 10 over 8. I'm going to have minus 3 over 8. I'm going to have minus 4 over 8. And then I'm going to have 2 over 8. I'm not going to leave it like that. I'm going to break it down or simplify it. So 2 into 10 goes 5. 2 into 8 goes 4. So that's going to be 5 over 4. Here, cannot break down any further, so it's 3 over 8. Here, this is a half. 4 into itself 1, 4 into 8, 2. So this is negative a half. And this one, 2 into itself 1, 2 into 4, that 2 into 8, that's 4. So I'm going to have a quarter here. So this would be the inverse for B. So sorry for the reflection, as I said before. I'm going to have to correct that in the next video. So that is how you find the inverse, that is how you find the adjoint, the determinant, and hence the inverse of a matrix. I'm going to work on another example. So sorry about the reflection in this video.